In this lesson, we will look at how to find the combined effect of multiple forces that are not acting in a straight line. We have learned in earlier lessons that a force is a vector and it has magnitude and direction. So when multiple forces are acting on an object in a straight line, we use vector addition to find the combined effect of the resultant force. What if the forces are not acting in a straight line? Let's find out how. Consider an airplane flying eastward with a forward thrust of 40 kN. The wind produces a force of 10 kN towards the north. To find the resultant force, we can use a scale of 3 cm to represent 10 kN and use arrows to represent the force of the aeroplane pointing eastward. This means that the 40 kN of the aeroplane is represented by a length of 12 cm. Then we do likewise for the force of the wind 10 kN pointing northward. Now how do we add up these two forces to find the combined effect? To do that, just imagine that instead of walking the long official distance, we take the direct path. This direct path is the resultant force. From our scale of 3 cm representing 10 kN, we can work out the magnitude of the resultant force by measuring the distance. Alternatively, you can use Pythagoras theorem to calculate the resultant force. What this whole thing means is that initially the airplane is flying eastward. When there's a wind producing a force of 10 kN, the force changes the direction of the aeroplane. The aeroplane now travels at an angle towards northeast. What if the two forces that is acting on the object is acting at an angle that is not a right angle? We can find the resultant for two forces acting at an angle by drawing a parallelogram as follows. The resultant will be the diagonal. This means that the effect of these two forces will cause the object to move in this direction, that is the direction of the resultant force. From this lesson, you can see that a force can change the direction of an object, and the effect of the forces acting on the object can be found through addition of vectors, because a force is a vector. In subsequent modules, we will learn what happens when the forces cancel each other and the resultant force becomes zero.